Hi everyone, I am Shekhar J and you are watching SJ Tech Videos. As I promised earlier, I am going to post a series of video tutorials on software testing. As part of that, today I am going to give you a detailed overview on software testing. This video is helpful to you guys to track where you are in the learning process of software testing, and to those guys who are curious about how things work in software testing. Okay, let's get started, but before that, please subscribe to the channel to get in touch with channel's updates and give this video a thumbs up if you like this video. Okay, according to me, overview is nothing but a combination of three questions, which are what, why and how. So let us apply for software testing, which will be like this. What is software testing, why to do software testing, and how to do software testing. Okay, basics first. So what is software testing? As the name indicates, we can say that testing a software application is called software testing. If you want a perfect definition for interview purpose, then we can say like this: verifying an application whether it is fulfilling all the requirements that are given in the functional requirements documents, business requirements documents, etc. documents, and cross-verifying the application for loopholes which are breaking the requirements directly or indirectly is called software testing. Simply, we can say that testing a software application with the intention of finding bugs is called software testing. Anyway, you don't need to hardly remember these definitions, as you are going to work on these concepts when you actually test a software application. So let's move on to why we have to test a software application. Nowadays, IT companies are becoming more competitive. So to improve and to protect their reputation, they must improve their quality, and they have to keep that quality to get new clients and to preserve them. So we can say that the term quality is the reason for testing a software. Okay, even if we keep the term quality aside, at least a company should give a bug-free product. And here the term quality and bug-free are not same. We will discuss the difference in later tutorials, as this tutorial is only intended for overview. Okay, besides all these reasons, finding a bug as soon as the coding has been completed will save the company and its reputation by decreasing the effect of that bug on time and money. Let us see an example to understand this scenario. Consider a module completed and it has a bug, but we did not recognize it. Then what happened is, all the other modules that developed based on this particular module will have bugs related to the bug in the first module. So it will consume both time and money to fix all those bugs. Unlike if we find that bug right after the module completed, it will prevent all the additional bugs related to it and saves time and money. These are the main reasons why we need to test a software application. So now let us get into the actual part, how to test a software application. Testing a software application is one of the phases in software development lifecycle. Here, software development lifecycle, in short, we can say SDLC, is a systematic process which is followed by IT companies to produce a software product. There are different types of software development lifecycle models. At present, most of the companies are following Agile model. We will discuss about these SDLC models in detail in later tutorials. Whatever the model it is, all are having some standard phases, which are requirements gathering, planning and analysis, designing, coding, testing, and release and maintenance. As we see here, after gathering the requirements, all the leads and main candidates will plan and analyze the requirements, that whether they can do the project or not, how many resources they're gonna need, and what will be the budget, etc. So after planning and analysis, the designing will be done with high level designing and low level designing. Here, Designing in application level is high level designing, and designing in module level is low level designing. After designing, developers will convert these designs into code. After completing the coding part, developers will perform unit testing and integration testing on the code that they developed, which is called as white box testing. Here, unit testing will have different sub-levels and integration testing will have different approaches to perform, which will be discussed on later tutorials. So after completing the unit testing and integration testing, developers will hand over the build to testing department to test. As soon as the testers get the build from developers, they will perform smoke test on the build. Here, smoke test is a test which is used to decide whether the build is stable or unstable to perform testing on it. If the build is unstable, they will send back the build to developers with smoke test results. And if the build passes the smoke test, testers will accept the build for testing phase. That's why smoke test is also called as acceptance test. After accepting the build for testing, testers will perform various kinds of testing as the end user, which is also known as black box testing. Through various kinds of testing, they will raise bugs, and then developers will fix that bugs, and then testers will close those bugs. After closing all the bugs, testers will generate the test report and will close the test. With this, the testing phase will get complete. Of course, there will be alpha testing and beta testing, but the actual part of testing will end with this phase. After this phase, the product will be released and maintained with supporting team. This is how testing involves in software development lifecycle. But if we consider testing phase, the testing phase itself has its own life cycle. As our main concentration is on testing, let us see the overview of testing life cycle. Okay, testing life cycle contains 6 phases, which are test initiation, test plan, test design, test execution, test report, and test closure. Okay, test initiation. In this phase, project manager will develop a strategy to test by considering overall project. Here, test strategy is a document which specifies which role is going to play by whom and who are responsible for what, and what kind of tests to conduct, and what are the risk factors, etc., etc. After preparing a strategy, project manager will select the suitable team leads for the current project. Then after that, project manager and team lead will form the team by considering some factors like project size, complexity, available time, budget, and resources, etc., etc. After that, the next phase is test plan. In this phase, the team lead will develop the test plan. Here, test plan is a document which defines a plan to test the application under test. Most of the companies will follow the IEEE 829 standard for test plan format. According to IEEE 829 standards, the test plan will have 16 attributes like test plan identifier, introduction, test items, features to be tested, features not to be tested, approach, testing tasks, etc., etc. Like this, we have 16 attributes which defines the plan of testing an application in detail. Through these 16 attributes, testers will plan like what features to test and what not to test, what strategy they have to use, and what are the resources they're gonna need, etc., etc. Simply, we can say that test plan is a plan which specifies that how to postmark the application under test. After test plan, testers will design the test which falls under test design phase. In this phase, testers are going to write scenarios and test cases. Here, a possible flow of application is called a scenario, and a particular issue to test in a scenario is called a test case. Let us take a small example to get better understanding on scenario and test case. Let's say an invalid username or an invalid password should not log the user into the system is a requirement. Here, login with invalid username and valid password will be a scenario, and valid username and invalid password will be second scenario, and both the fields invalid is third scenario, and both the fields blank will be fourth scenario. Here we get four scenarios for the particular requirement. If we see the first scenario, which is invalid username and valid password, the different inputs that provides invalid username and valid password will become different test cases. Okay, designing test scenarios is called high-level test design, and we have four methods to design scenarios, which are functional requirements based test design, non-functional requirements based test design, use case based test design, and user interface based test design. Applying these techniques, testers will develop various scenarios of requirements. That is about scenario designing. Let us see about test case designing. Designing test case is also called as low-level test design. There are mainly four techniques to design test cases. They are boundary value analysis, equivalence partition analysis, decision table, error guessing. Depending on the scenario, it may be single technique or all the techniques applicable to a scenario to design test cases. Like this, for a requirement, there will be multiple scenarios or a single scenario, and for a scenario, there will be multiple test cases or a single test case. That is about overview of test design. The next phase is test execution. In this phase, testers are going to execute the test case and test scenarios in four levels. There are level 0, which is mock testing, level 1, which is real testing, level 2, which is retesting and regression testing, and finally it's level 3, which is final testing. In level 0, testers will execute the important test cases only, which is called smoke testing. As we discussed earlier, here testers will observe some factors like whether the build is understandable, operable, maintainable, and testable, etc. etc. After that, in level 1, testers will do the real testing by executing all the scenarios and test cases. Here come all variety of testing like functional testing, non-functional testing, load, stress, etc. etc. If they found any deviation, they will raise a bug in some issue tracking tools, or they will make a bug report manually. Nowadays, all companies are using some tracking tools. After level 1, the developers will fix the bugs, and then the level 2 will start, which is retesting and regression testing. In level 2, testers will do retesting and regression testing. Here, retesting is nothing but testing the application again to know that the bugs that raised previously are fixed or not. If the bugs are not fixed, they will reopen the bugs, otherwise they will close those bugs and do regression testing. Here, regression testing is nothing but testing the application for new bugs which may caused due to fixing of previous bugs. If they find new bugs, the level 2 will repeat again, which is retesting and regression testing for the newly raised bugs. If retesting and regression testing completed successfully, then the test execution level will pass to level 3, which is final testing. Here, team lead will identify highest defects density module. On that module, testers are going to conduct retesting to find out the reasons why they have got that many defects, so that they can take precautions for future projects. So this is all about test execution. The next phase is test report phase. In test report phase, testers will prepare reports with the test execution results, like how many test cases prepared, how many executed, how many skipped, how many fail, how many pass, etc. etc. All the test deliverables will be finalized to submit to the project manager, and the final phase is test closure. In test closure phase, testing team will conduct different analysis like coverage analysis, defect density calculation, defect analysis, tester performance analysis, etc. etc. This is the process of testing a software application in real time. This is all about software testing life cycle. But hey, where is this manual testing and automation testing comes from? Okay, let us see that too. Most people say simply testing manually is called manual testing, and testing with some automation tools is called automation testing. But let me give you a further clarification. Manual testing and automation testing mostly happens in the test execution phase. Let us say some company developing an application of some 15 modules. After the second module completion, they have to test the first module also to see integration and communication between these two modules, and they have to ensure that there is no bugs in first module due to the implementation of second module. Like this, they have to test every module that is related to the latest developer module. So in this scenario, the automation comes into picture. For long-term projects, they will start automating test cases soon after they get a stable module as a result of manual testing. So we can say that the automation will not replace manual testing. It is an extension to manual testing to comfort the testing process. So what we can automate mainly is retesting, regression testing, which comes under functional testing, and load testing, stress testing, which comes under performance testing. Okay, let's conclude. So to start your career in software testing, you have to learn developing test plan, test designing, which includes both scenarios and test cases, test execution, both manual and automation, and test reporting. Test initiation and test closure knowledge will get to you with some experience. Don't bother about those if you are a fresher. So that's all about detailed overview on software testing. I'm going to post videos on complete manual testing and automation testing in near future. So to get all those updates right away, please subscribe to my channel, and please like and share this video if you found this video informative. If you want to give me any feedback or suggestions, please post it in comments. Thank you. I am Shekhar J, and you are watching SJ Tech Videos. See you in the next video.